Please like and share my videos, and I request you to subscribe my channel if you have not already subscribed. 14 questions were given from the topic Limits, Continuity and Differentiability from the chapter Differential Calculus in the JEE Main Examination held in January 2024 session. The first 8 questions were already made videos and they are available in my channel. We now discuss the solutions of the questions 9 to 14 in this video. This question has appeared in the JEE Main exam held on 31st January 2024 in the second shift. The given problem is limit extends to 0 of ax square into e power x minus b multiplied by log of 1 plus x to the base e plus cx into e power minus x by x square sin x is equal to 1. Then 16 times in brackets a square plus b square plus c square is equal to. Let's now discuss the solution of the problem in detail. Limit x tends to 0 of the given expression is equal to 1. To evaluate the limit, we write down the Maclaurin's expansion of e power x and log of 1 plus x to the base e and e power minus x and do some manipulation. So limit x tends to 0 ax square into the Maclaurin's expansion of e power x minus b into the expansion of log of 1 plus x to the base e plus cx into the expansion of e power minus x. And we have multiplied and divided by x, and thereby in the denominator you will get x cube multiplied by x by sin x. The sin x is adjusted here. Agreed. Now multiply and write it as the coefficient of x plus the coefficient of x square plus the coefficient of x cube plus the coefficient of x to the power of 4 by x cube. So that is limit x tends to 0 c minus b into x plus a plus b by 2 minus c into x square, that is the coefficient of x square. Collect the coefficient of x cube from the above, you will get ax square into x, ax cube, a minus b by 3 plus c by 2 into x cube plus the coefficient of x to the power of 4 plus so on and so forth into limit x tends to 0 of x by sin x is equal to 1. We have used the formula limit of the product is equal to product of their limits. And we know limit x tends to 0 of x by sin x is 1. And we write down this as limit x tends to 0, the coefficient of x plus the coefficient of x square plus the coefficient of x cube by x cube plus in all the remaining terms you will have x power 4, x power 5, x power 6 and divided by x cube you will get limit x tends to 0, the coefficient of x to the power of 4 by x cube, x. So, and limit x tends to 0, a by 2 plus b by 4 plus c by 6 in brackets x plus so on and so forth. The remaining terms, all the remaining terms in this contain x. As x tends to 0, all this whole thing becomes 0 because it is x, x square, so on and so forth were there. Right. So this becomes 0. This becomes 0. Now, in the first one, we write limit x tends to 0, c minus b into x plus a plus b by 2 minus c in brackets x square by x cube plus limit x tends to 0, a minus b by 3 plus c by 2 x cube by x cube. So this limit will be a minus b by 3 plus c by 2. Right. And the limit exists. It is given. This limit exists and is finite. When this is possible? When this is possible? This is possible if you have c minus b is equal to 0 and a plus b by 2 minus c is equal to 0. If you say this is not possible, then limit x tends to 0, c minus b into x plus a plus b by 2 minus x square by x cube. This does not exist. Therefore, you must have c minus b is equal to 0 and a plus b by 2 minus c is equal to 0. So, you must have c minus b is equal to 0 means b is equal to c, a plus b by 2 minus c is equal to 0. In that, substitute c is equal to b, you will get b is equal to c and a is equal to b by 2. From here, you will get a minus b by 3 plus c by 2 and that is equal to 1. Thus, we have 3 equations in 3 unknowns and solve them. On solving, we will get a is equal to 3 by 4, b is equal to c is equal to 3 by 2. What is that we want? We want the value of 16 times a square plus b square plus c square. That is equal to 16 times a square 3 by 4 whole square 9 by 16 plus b square 3 by 2 whole square that is 9 by 4 plus c square that is 3 by 2 whole square that is 9 by 4. So that is 16 times 9 plus 72 by 16, right? So on cancellation you will get 9 plus 72 that is 81. So therefore the answer to this question is 16 times a square plus b square plus c square is equal to 81. That is the detailed discussion of the solution of this problem. We now move to the next problem. This problem has appeared in the JEE Main exam held on 31st January 2024 in the second shift. The given question is, consider the function f from the open interval 0, infinity to r, the set of real numbers defined by f of x is equal to e power minus modulus of log x to the base e. If m and n respectively the number of points at which f is not continuous and f is not differentiable, then m plus n is. So we are given a function f from the open interval 0 to infinity to r, the set of real numbers defined by f of x is equal to e to the power of minus of mod of log x to the base e. And m and n are respectively the number of points at which f is not continuous and f is not differentiable, then m plus n is. We are given 4 options. Right. We now discuss the solution of the problem in detail. We have the function defined like this. Right. Now f of x is equal to, now let us see what is log x to the base e in the interval 0 to 0 less than x less than 1. In the open interval 0 to 1, log x to the base e is negative. We all know. And when x greater than or equal to 1, log x to the base e is greater than or equal to 0. Right. So that is why in the interval, open interval 0 to 1, mod of log x to the base e is minus of log x to the base e. And when x greater than or equal to 1, it will be e power minus log of x to the base e. Because log x to the base e is positive, is greater than or equal to 0 when x greater than or equal to 1. So that is why it has come like that. So this is equal to e to the power of minus and minus log x to the base e when 0 less than x less than 1, e to the power of minus log x to the base e when x greater than or equal to 1. So what is e to the power of log x to the base e? It is very well known. It is x. And e to the power of minus log x to the base e is 1 by x. So this is equal to f of x is equal to x in the open interval 0 to 1 and 1 by x when x greater than or equal to 1. Now it is very easy to see that this function fx is continuous everywhere except possibly at x is equal to 1. But at x is equal to 1, the left limit is 1. At x is equal to 1, the right limit is also 1. So they are equal, therefore it is continuous at x is equal to 1. Thus, this function f of x is continuous everywhere. Right. And now we can draw the graph of f of x very easily, because f of x is equal to x is a straight line in the open interval and 1 by x is a parabolic path in the for x greater than or equal to 1. Let's look at the diagram. Right. So fx is equal to x in the open interval 0 to 1 is this one. This is x, y is equal to x, and for x greater than or equal to 1, it is 1 by x, y is equal to 1 by x. This is the parabolic path, and we have already discussed this continuity at the joining point, namely 1, 1. So it's continuous everywhere, therefore there are no discontinuities, therefore m is equal to 0. And what about the differentiability at this point 1, 1? You see that there is a steep corner at the point 1, 1, then the differentiability will be lost at 1, 1. So f of x is differentiable everywhere except at the point x is equal to 1. So the number of discontinuities is 1. So it may be seen that f of x is constant on continuous. f of x is continuous on the open interval 0 to infinity, right? And m, the number of points at which f is not continuous is 0, because this is continuous on the whole of 0 to infinity. Right? And further, fx is not differentiable at x is equal to 1 because the graph has a steep corner at 1, 1. When you have steep corners in the graph, then the differential will be lost at that point. Therefore, n is equal to the number of points at which f is not differentiable is 1. Required to find the value of m plus n, that is equal to 0 plus 1 is equal to 1. So let's look at our options. Our answer 1 appears against option 2. Therefore, the answer to this question is option 2. And that is the detailed discussion of the solution of this problem. And it is definitely an easy question. Let's now move to the next question. This question has appeared in the JEE Main examination held in 1st February 2024 in the first shift. The given question is, let curly bracket x denote the fractional part of x, and the function f of x is given by cos inverse of 1 minus curly bracket x square into sine inverse of 1 minus curly bracket of x whole by, in the denominator, curly bracket x minus curly bracket x cube when x not equal to 0. If capital L and R respectively denote the left hand limit and the right hand limit of f of x at x is equal to 0, required to find the value of 32 by pi square into L square plus R square. Right. So first of all, for any real number x, we have x is equal to bracket x, that is the greatest integer less than or equal to x, plus curly bracket x, where curly bracket x is the fractional part of x. And these things are well known to us. Right. Now, as x tends to 0 plus, so you have to, on the real numbered line, x tends to 0 plus means x is tending to 0 from right. In that neighborhood, what is bracket x? The bracket x is 0 and x will become curly bracket x. As x tends to 0 minus, that means x is tending to 0 from the left, then what is the bracket x? That is the greatest integer less than or equal to x will be minus 1 plus the curly bracket x, the fractional part. So, as x tends to 0 plus, bracket x is x only. As x tends to 0 minus, curly bracket x is x plus 1. So, we are ready now to compute the left hand limit and right hand limit of f of x at x is equal to 0. Right. Now, capital R is the right hand limit is equal to limit x tends to 0 plus of f of x. In f of x, wherever curly bracket x is there, you write down x. And that will be limit x tends to 0 cos inverse of 1 minus x square multiplied by sine inverse of 1 minus x by x minus x cube. That is capital R. Right. Now, when you go for L, capital L, that is the left hand limit, that is limit x tends to 0 minus of f of x, and wherever there is bracket x, you write down x plus 1. So, limit x tends to 0 minus of f of x is equal to, wherever there is curly bracket x, you write 1 plus x. Right. So therefore, capital L is this one. Now we take this capital R and L, we will evaluate them in the next slide. Right. We have R, limit x tends to 0, cos inverse of 1 minus x square into sine inverse of 1 minus x by x minus x cube. And we have L is sine limit x tends to 0 of cos inverse of 1 minus in brackets 1 plus x whole square into sine inverse of 1 minus 1 plus x by 1 plus x minus 1 plus x whole cube. Let's first of all evaluate capital R. This is equal to limit x tends to 0 cos inverse of 1 minus x square by x into sine inverse of 1 minus x by 1 minus x square. So x minus x cube is written as x into 1 minus x square. X is written here and 1 minus x is written here. Limit of the product is equal to product of their limits. That's what we are applying. And let us look at the second limit. Limit x tends to 0 of sine inverse of 1 minus x by 1 minus x square is, when you evaluate, it is sine inverse of 1. Right. So sine inverse of 1 is pi by 2. Right. And this is equal to limit x tends to 0 of the first expression into sine inverse of 1. Sine inverse of 1 is pi by 2 into limit x tends to 0 of cos inverse of 1 minus x square by x. Right. Now, as x tends to 0, 1 minus x square will be 1 by 0. Cos inverse of 1 is 0 by 0. It takes the form 0 by 0 form, which is an indeterminate form. To evaluate this one, we apply L'Hopital's rule. That is, pi by 2 into limit x tends to 0, the different derivative of the numerator by the derivative of the denominator. Pi by 2 into limit x tends to 0, the derivative of cos inverse of 1 minus x square is minus 1 by under the square root of 1 minus x square whole square into the derivative of minus x square is minus 2x by 1. Right. Simplify. Pi by 2 into limit x tends to 0 of 2x by under the square root of 2x square minus x to the power of 4. Please simplify. Right. Right. And this is pi by 2 into limit x tends to 0 of 2x by, in the denominator we have taken a x common. So x times under the square root of 2 minus x square. So pi by 2 into 2x. So when you take the limit will be 2 cancelled here. When you take the limit as x tends to 0, it is x cancelled, of course. Limit x tends to 0 will be 1 by under the square root of 2 minus x square, that is 1 by root 2. So the capital R value is pi by root 2. Agreed. Let's get into the evaluation of capital L. Right. Right. Now, limit x tends to 0 cos inverse of 1 minus 1 plus x whole square. When you expand, 1 cancels and you get minus 2x minus x square into sine inverse of 1 minus of 1 plus x. 1 cancels is sine inverse of minus x. And in the denominator, you take 1 plus x common. Then you will get in brackets 1 minus 1 plus x whole square. Right. Right. Now, that's equal to limit x tends to 0 cos inverse of minus 2x minus x square by 1 plus x into limit extends to 0, sine inverse of minus x by minus 2x square minus x square. Agreed. As extends to 0, this is cos inverse 0 by 1. Cos inverse 0 is pi cos inverse 0 multiplied by limit extends to 0. This is written as the product sine inverse of minus x by x into limit extends to 0 1 by minus 2 minus x. Cos inverse 0 is pi by 2 and the limit extends to 0 sine inverse minus x by x takes the 0 by 0 form and use L'Hopital's rule. The derivative of the numerator is minus 1 by under the square root of 1 minus x square by the derivative of x is 1 into limit extends to 0 1 by minus 2 minus x is minus 1 by 2. Now this is equal to pi by 2 into and the limit extends to 0 of this one is 1. Minus into minus plus into 1 by 2. Then you will get the value pi by 4. So the value of r is pi by root 2. The value of capital L is pi by 4. What is that we want? We want 32 by pi square into L square plus r square. And that is equal to 32 by pi square multiplied by pi square by 2, that is pi by root 2 whole square, plus pi by 4 whole square, that is pi square by 16, and simplify, you will get 16 plus 2, that is 18. That is the detailed discussion of the solution of the given problem. It takes a little bit of time, but otherwise it is an easy question. Let's now move to the next question. The given question has appeared in the JEE Main exam held on 1st February 2024 in the first shift. The given question is, let f be a function from R into itself, where R is the set of real numbers, be defined as f of x is equal to a minus b cos 2x by x square when x less than 0, when 0 less than or equal to x less than or equal to 1, f of x is given to be x square plus cx plus 2. When x greater than 1, f of x is given to be 2x plus 1. If f is continuous everywhere on the whole of the real number line and m is the number of points where f is not differentiable, then m plus a plus b plus c equals, we are given 4 options. Right. Let's now discuss the solution of the problem in detail. So we have this function from R to R defined like this. Agreed. And what is given, and this function is given to be continuous on the whole of the real number line. That means at these points x is equal to 0 and x is equal to 1, also it is continuous because it is continuous everywhere. Because in this definition of the function f of x, there is a shift in the definition when at x is equal to 0 and at x is equal to 1. So it is given, it's continuous everywhere, therefore it's continuous at x is equal to 0. F is continuous at x is equal to 0 and the value of f at 0 is equal to f of 0 minus. F of 0 minus. That is why we have taken f of 0? F of 0 is at x is equal to 0, f is defined, and that means the right hand limit is this value of the function because it's continuous. F of 0 minus, and f of 0 is 2 is equal to f of 0 minus is limit x tends to 0 a minus b cos 2x by x square. This will imply 2 is equal to limit x tends to 0 a minus b into the Maclaurin's expansion for cos 2x by x square. Then it will be limit x tends to 0 a minus b plus b times in brackets 2x square minus 2x to the power of 4 by 3 plus so on and so forth. This is limit x tends to 0 a minus b by x square plus 2b, because x square cancels, you will get 2b. The other terms will become 0 because they contain the terms x square, so on and so forth. And now because the limit exists and it is finite, this is possible when a minus b is equal to 0. Since the limit exists and is finite, we must have a minus b is equal to 0. So a minus b is 0, and you will get 2b is equal to 2. Thus, you will get a minus b is equal to 0 means a is equal to b, and from the above 2b is equal to 2. So 2b is equal to 2 means b is equal to 1, a is equal to b is equal to 1. So those are the values of a and b. We have used the fact that f is continuous everywhere in R. Second, f is continuous at x is equal to 1. Therefore, at x is equal to 1, f of 1 is defined. F of 1 is equal to f of, as x tends to 1 from right, that is f of 1 plus. So f of 1 is 1 plus c plus 2 is equal to limit x tends to 1 of 2x plus 1. Because it is the right limit, you have to use this. And take the limit, that will be 2 plus 1, that is 3. So 3 plus c, 1 plus c plus 2, that is 3 plus c is equal to 3. This implies c is equal to 0. Thus we have got the values of a, b, c. A is equal to b is equal to 1 and c is equal to 0. In the next slide, we talk about the differentiability of the function. So we have those values and we have f of x. Recall this one, just simply cut and paste. And put the values of a, b, c in this. So then you'll get this one. And now you see 1 minus cos 2x is 2 sin square x by x square. That is 2 into sin x by x whole square when x less than 0. So the function f of x is here. Right. Now take the differentiation. F prime x is equal to 2 times d by dx of sin x by x whole square, and the differential of x square plus 2 is 2x. The differential of 2x plus 1 is 2, and the intervals are x is less than 0, 0 less than or equal to x less than or equal to 1, x greater than 1. And f prime x exists everywhere except possibly at x is equal to 0, at x is equal to 1. But we have f prime at 0, that is 2 into 0, 0. That means it is differentiable at x is equal to 0. Agreed. At x is equal to 1, so f prime of 1 minus is what? In this, x is tending to 1 from left, that is limit x tends to 1 of 2x, that is 2. Now the right hand derivative, f prime of 1 plus, and it is fixed 2. It is 2. So they are equal. Therefore, fx is differentiable at x is equal to 1. Thus, fx is differentiable at x is equal to 0 and x is equal to 1. And fx is differentiable on the whole of the real number line. Right. So that means now m, the number of points where f is not differentiable, it is differentiable on the whole of R, that is 0. That is 0. Required to find the value of m plus a plus b plus c. And m value is 0, a 1, b 1, c is 0. And the answer is 2. So let's look at our options. The value of m plus a plus b plus c is 2, is appearing against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of the given problem, and it is little tedious, but it can be done in the examination. Right. Let's now move to the next question. This question has appeared in the JEE Main exam held on 1st February 2024 in the second shift. The given question is f of x is equal to x minus 1 when x is even, and f of x is equal to 2x when x is odd, where x belongs to the set of natural numbers capital N. If for some a belongs to n, f of a is 21, then limit extends to a minus, that is the left hand limit of at a, of in brackets mod x cube by a minus bracket of x by a, where bracket t denotes the greatest integer less than or equal to t, is equal to. Yes. Now we are given 4 options. Right. Let's now discuss the solution of the problem in detail. Take the definition of f of x. F of x is x minus 1 when x is even. F of x is 2x when x is odd, where x belongs to the set of natural numbers. Agreed. Let's now take f of a is equal to 21. Let a belongs to n first, case 1. Let a belongs to n and a is odd. When a is odd, f of a is 2a. Right. Then f of a. So the innermost f of a is 2a. So it is f of 2a. Now the innermost f of 2a. For any natural number a, 2a is an even natural number. So f of 2a will be, by definition, 2a minus 1. So f of 2a minus 1. And for any natural number a, 2a minus 1 is odd. Therefore, it will be 2 times 2a minus 1. But this is given to be 21. So now, this is equal to 21 will imply 2 into 2a minus 1 is equal to 21. Now, where a is a natural number, now you do not find any solution in the set of natural numbers. No a belongs to n satisfies this equation. Right. So that's the case when a is odd. Let's now move to the second case when a is even. So then f of a, when a is even, the innermost f of a, when a is even, is the a minus 1. So it will be f of a minus 1. When a is even, a minus 1 is odd. Therefore, it will be f of a minus 1 will be 2 times of a minus 1. Now apply f on it, and this is even because 2 times of that. So when it is even, it is minus 1. 2 into 2a minus 1 minus 1. When you simplify, you will get 2a minus 3. But it is given to be 21. So 2a minus 3 is 21. And solving, you will get a is equal to 12. Agreed. Now let's go and evaluate the limit. Limit x tends to a minus of this expression is equal to limit x tends to 12 minus, because a is 12, of mod x cube by 12 minus the bracket x by 12. Right. And now we will now take limit h tends to 0 for x. We write 12 minus h because it is from the left. 12 minus h whole cube by 12 minus the bracket 12 minus h by 12. Now 12 minus h by h cube by 12, as h tends to 0, it is 12 cube by 12. And 12 minus h will be less than 12 by 12. That means it is less than 1. The greatest integer is 0. So that is equal to 12 cube by 12 minus 0. That is 12 square by 12. That is 144. So let's look at our options. And the answer 144 appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of the given problem. It is definitely a very easy question. Let's now move to the next question. This question has appeared in the JEE Main exam held on 1st February 2024 in the second shift. The given question is, let f of x is equal to mod of 2x square plus 5 times mod x minus 3, where x belongs to the set of real numbers. If m and n denote the number of points where f is not continuous and not differentiable respectively, then required to find the value of m plus n. And we are given 4 options. Now, and many of them, they say, and they give the graph of f of x is equal to mod of 2x square plus 5 times mod x minus 3. And get the answers from that graph. But for me, the graph of this one may be drawn if you use some kind of a software like Desmas. But that is not needed here, because in the examination we don't have any software that is available to us. So therefore that drawing a graph and drawing conclusions from that, I don't say. Therefore, without the graph, I would like to work out this problem. Let's now discuss the solution of this problem. We have f of x is equal to mod of 2x square plus 5 times mod x minus 3, where x belongs to R. Agreed. Now, we talk about the continuity. Now you see 2x square is a polynomial. Polynomial is continuous. Mod x is continuous. Minus 3 constant is continuous. So it is the sum of continuous functions. Therefore it's continuous. So which is continuous? 2x square plus 5 times mod x minus 3 is continuous on the whole of the real numbered line, since it is the sum of continuous functions. And we know the sum of continuous functions is again continuous. And f of x is mod of this one. So mod of a continuous function is again continuous. Therefore f of x is equal to mod of 2x square plus 5 times mod x minus 3 is continuous on R. Therefore there are no discontinuities for this function. So thus m, the number of points where f is not continuous, is 0. So now the question is to talk about its differentiability. Right. So f of x, we write it that is equal to mod of 2x square plus 5 times mod x minus 3, and write down as two expressions like this. When x is negative, mod x will be minus x. When x greater than or equal to 0, mod x is plus x. So it will be mod of 2x square minus 5x minus 3 when x is negative, mod of 2x square plus 5x minus 3 when x is greater than or equal to 0. We continue in the next slide. Right, that's what we have. And now we deal with two cases. Case 1, when x is negative. When x is negative, mod of the function, let's take the function 2x square minus 5x minus 3, this function, and factorize. You'll get 2x plus 1 into x minus 3. Agreed? Agreed? And where this 2x plus 1 into x minus 3 is greater than or equal to 0. That is 2x plus 1 is equal to 0 will give you x is equal to minus 1 by 2. And if x less than or equal to minus 1 by 2, then you will get 2x plus 1 is negative, is also 0 and negative. And x less than or equal to minus 1 by 2, x minus 1 by 3 is also negative. So negative into negative, positive, greater than or equal to 0 if x less than or equal to minus 1 by 2. Right, what happens? What happens when, and mind you, x less than 0. X less than 0 means what is left over? Minus half less than x less than 0, because up to 0 only. So in that it is negative. Why it is negative? Minus 1 by 2 less than x means 2x plus 1 is greater than 0. Is greater than 0. And this is also, now 2x minus 1 by 2 less than x, and that will be 2x plus 1 greater than 0, and this is also greater than 0. This is negative. This is negative because x is equal to minus 1 by 2 you put, it is negative. it is positive, it is negative. So the product is negative. So that is what is this one. So case 2, when x greater than or equal to 0, 2x square plus 5x minus 3, factorization, 2x minus 1 into x plus 3, argue as above. You will see it is less than 0 if 0 less than or equal to x less than 1 by 2, and it is greater than or equal to 0 if x greater than or equal to half. Mind you, x greater than or equal to 0 you have to consider. So now it is broken into 4 pieces now. So f of x will be when x less than or equal to minus 1 by 2, it is greater than or equal to 0. Therefore, mod of that is 2x square minus 5x minus 3. When minus half less than x less than 0, it is negative. Mod of that is a negative minus of 2x square minus 5x minus 3. This one only. Right. So, when 0 less than or equal to x less than half, it is negative. In the second case, when it is negative, minus of 2x square plus 5x minus 3. And when x greater than or equal to half, it is greater than or equal to 0. Therefore, mod of that is just function 2x square plus 5x minus 3. Thus, we got the whole of the function fx. Even if you know this much, drawing a diagram will be difficult. So let's now have the function. We are talking about differentiability. Differentiate. F prime x is equal to 4x minus 5. In this x less than or equal to minus 1 by 2. Here minus 4x plus 5. When minus half less than x less than 0. Minus 4x minus 5. When 0 less than or equal to x less than 1 by 2. And 4x plus 5 when x greater than or equal to half. Now discuss now the differentiability. Right? So we go to the next slide. We have m is equal to 0. We are talking about differentiability. We have f prime x here. Now this f prime x exists everywhere except possibly at x is equal to minus 1 by 2, at x is equal to 0, at x is equal to half. At these 3 points, we have to discuss its differentiability. So that means f of x is differentiable everywhere except possibly at x is equal to, except possibly at x is equal to minus 1 by 2, at x is equal to 0, at 1 by 2. Right. So that means the left hand derivative, right hand derivatives at these 3 points you have to compute. That we have done it here. So the left hand derivative at minus 1 by 2. The left hand derivative at minus 1 by 2 is 4x minus 5 when x is minus 1 by 2. So that is minus 7. The right hand derivative at x is minus half. That means minus 4x plus 5 when x is minus half. So that is 7. They are not equal. So the right hand derivative is not equal to the left hand derivative at x is equal to minus 1 by 2. Therefore, f of x is not differentiable at x is equal to minus 1 by 2. Now, what happens at x is equal to 0? At x is equal f prime 0 minus means here. 0 minus means here. And this is minus 4 times 0 plus 5. F prime 0 plus means here it is minus 5. So they are not equal. Therefore, f of x is not differentiable at x is equal to 0. And the left hand derivative, right hand derivative at 1 by 2. So the left hand derivative is at 1 by 2. So in this expression, you substitute x is equal to minus 1 by 2. So it will be minus 7. The right hand derivative is in this 4 into 1 by 2 plus 5, that is 7. Agreed. Agreed. They are not equal. Therefore, fx is not differentiable at x is equal to 1 by 2. So, summarizing all this, f of x is not differentiable at 3 points. What are those points? X is equal to minus 1 by 2, x is equal to 0, x is equal to 1 by 2. N, it is given to us the number of points where m is not differentiable, they are 3. They are 3. What is to be found out? So, required to find the value of m plus n, that is 0 plus 3, that is equal to 3. So, let's look at our options. Our answer 3 appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of this problem. And in this video, we have discussed 6 questions from 9 to 14. 9 to 14, 6 questions. I am sure that you have understood the solutions of these problems. And I am sure that you have understood the questions, these 6 questions and their solutions that are discussed in this video. If you like my videos, please like, share and subscribe. I wish you all the best. Thank you.